The Long Island Water Quality Challenge is a competition that promotes project-based learning in science, technology, engineering, and mathematics with a specific focus on protecting Long Island's waters by reducing or eliminating nitrogen pollution. Nitrogen pollution has been found to be the leading cause of water quality deterioration on Long Island. The Long Island Water Quality Challenge is associated with LINAP, the Long Island Nitrogen Action Plan, a multi-year initiative to reduce nitrogen in Long Island's groundwater and surface water through technical, management, regulatory, and policy action. A safe supply of clean drinking water and healthy creeks, ponds, bays, and harbors are important to the quality of life of nearly 3 million people living in Nassau and Suffolk counties. Here on Long Island, we are dependent on and benefit from the vast water resources of the region. Our water resources support a multi-billion-dollar economy fueled by tourism, boating, and fishing. But more importantly, Long Island is also home to a sole source aquifer, which means all of Long Island's drinking water comes from the ground. Groundwater, which is water found underground in the cracks and spaces of soil, sand, and rock, also feeds all the lakes, streams, bays, and harbors throughout the island. Unfortunately, groundwater contamination is increasing and threatening our drinking water and waterways, and one of the biggest culprits is excess nitrogen. The Long Island Nitrogen Action Plan STEM Challenge is taking place because of the critical need to better protect our water resources and to improve water quality where it has become degraded. In this presentation, we will cover four main topics: the sources of nitrogen pollution, the impact of nitrogen on our environment, the role of LINAP, and lastly, the Long Island Water Quality Challenge and how you can play a part in reducing nitrogen pollution on your school grounds. Each small step can lead to significant changes in reducing nitrogen pollution to improve our waterways. There are several significant sources which can lead to nitrogen pollution. We will explore where excess nitrogen comes from and how it pollutes our water here on Long Island and across the globe. Wastewater is by far the largest contributor to nitrogen pollution on Long Island. Wastewater is the water that we use in our homes each day when we shower, flush the toilet, wash our hands, and run the dishwasher. Water leaving our homes generally goes into either a septic tank or cesspool in our yard, or is sent to a wastewater treatment facility through a sewer system. On Long Island, there is a large reliance on cesspools and septic systems, which are simply not designed to remove nitrogen. In fact, over 70%, or approximately 360,000 homes, have septic tanks or cesspools in Suffolk County alone. Fertilizer contains nitrogen and represents a substantial portion of the nitrogen load in some areas of Long Island. Fertilizers are used on our lawns, golf courses, soccer fields, parks, and farms. If used improperly, fertilizers can become a source of nitrogen pollution and harm Long Island's groundwater and water bodies. Rain and snow flow over our streets, roofs, parking lots, and other hard surfaces before directly entering a storm drain or water body. As the water travels, it picks up fertilizer along with other waste and pollutants. The water can flow directly into a storm drain or water body without the opportunity for a water treatment facility or soil and plants to filter out excess nitrogen. Atmospheric deposition is a process where substances in the air come in contact with rain, snow, or other forms of precipitation and get carried down to the Earth's surface. When there are increased concentrations of nitrogen and other pollutants in the atmosphere from human activities, it can have a negative effect on our health and land and marine ecosystems. Some contributing activities include car emissions, industry, littering, using fertilizer, and waste from animals. How does nitrogen affect our water quality? Through groundwater drainage and surface water runoff, nitrogen reaches our coastal waterways and inland water bodies. Excess nitrogen in these surface waters can bring about excess algal growth, also known as harmful algal blooms. High levels of nitrogen can also degrade salt marshes and critical marine habitats such as eelgrass. In addition, rising levels of nitrogen in groundwater is a concern where groundwater will be used as a drinking water source. Nassau and Suffolk counties depend on the underground water table as the sole source of drinking water. Fortunately, there are solutions, and schools can play a role when it comes to stormwater management. Living on Long Island, we have all witnessed a harmful algal bloom, often known as red tides, rust tides, or brown tides. Algal blooms are caused by excess plant growth, which can result in low or no oxygen conditions in the water, creating an environment that can be harmful to marine life and cause fish kills and shellfish to die off. A record-setting number of fish kills on Long Island occurred during the summer of 2022. A salt marsh is a coastal wetland flooded and drained by salt water brought in by the tides. Salt marshes provide a critical habitat for numerous marine species and birds, as well as a nursery area for commercial and recreational fish. These marshes also protect coastal communities and infrastructure by acting as a natural storm barrier, and they also filter out water pollutants such as nitrogen. Nitrogen pollution is contributing to the degradation of salt marshes, the loss of critical marine habitats, and it makes us more vulnerable to the impact of major storms on Long Island. According to this year's assessment of water quality by the Gobler Lab at Stony Brook University, there were a record number of fish kills, oxygen-starved dead zones, and algal blooms in every major bay and estuary on Long Island this past summer. There was a tenfold increase in the number of fish kills. More than 20 of Long Island's lakes and ponds had toxic blue-green algal blooms, and more than 24 had low oxygen dead zones. For the past 6 years, Suffolk County has had more lakes with blue-green algal blooms than any other of the 64 counties in New York State. Blue-green algae makes toxins that can be harmful to humans and animals and has been linked to dog illnesses and dog deaths across the U.S. and on Long Island. Lineup is looking at where nitrogen is coming from, how it is getting into the water, and how much nitrogen removal is necessary to make our water healthy again. The specific goals of Lineup are to assess nitrogen pollution in Long Island's water, identify what sources are bringing nitrogen to surface waters and groundwater, establish nitrogen reduction endpoints, and develop action plans to reduce nitrogen in order to achieve the best possible water conditions. Lineup is a team effort. There is a broad partnership working together to develop and put into effect the Long Island Nitrogen Action Plan. The partnership includes the New York State Department of Environmental Conservation, the Long Island Regional Planning Council, Suffolk and Nassau counties, local governments, area scientists, and numerous environmental groups and non-governmental organizations. Suffolk and Nassau counties are taking great steps to reduce nitrogen loading from wastewater by improving existing wastewater treatment plants, expanding sewering where possible, and replacing outdated septic and cesspool systems with innovative alternative on-site wastewater treatment systems. Innovative alternative on-site wastewater treatment systems are designed to significantly reduce nitrogen pollution. Both counties on Long Island, along with funding from New York State, have developed septic replacement grant programs, which provide grants and loans to homeowners to replace their outdated systems with this new technology. Other initiatives include bioextraction. Bioextraction is the practice of farming and harvesting shellfish and seaweed for the purpose of removing nitrogen from water bodies. Shellfish and seaweed are natural filters that can absorb nitrogen from the water. Lineup is also investigating the potential value of groundwater intercept technologies. These new technologies intercept nitrogen-polluted groundwater before it reaches surface water. Fertilizer management recommendations have also been developed to help property owners reduce the environmental impact of their lawn and other grassed areas. These recommendations were developed with input from various areas, including landscapers, fertilizer manufacturers, golf courses, environmental groups, and state and county government. Both counties have also conducted sub-watershed planning, which is an in-depth watershed analysis which identifies and focuses on all impaired water bodies, the sources of nitrogen in those areas, and long-term plans to reduce nitrogen. You and your school can make an impact by improving the management of stormwater runoff through incorporating green infrastructure onto school grounds. The focus of the Long Island Water Quality Challenge is to use project-based learning in science, technology, engineering, and math with a focus on the role that green infrastructure can play to better protect and improve the quality of surface and groundwater by addressing nitrogen pollution. On Long Island, we are never far from surface waters and groundwater, and that holds true for most schools in Nassau and Suffolk counties. Stormwater runoff on school property can transport nitrogen pollution along with other contaminants through the watershed and into groundwater and coastal waterways. Smart management practices to reduce and contain nitrogen pollution on school grounds can help to protect the ecological health of our bays, as well as local streams, creeks, ponds, and lakes, and the quality of our drinking water too. Green infrastructure refers to a wide array of actions that restore, protect, and imitate the natural water cycle. Green infrastructure uses soil, vegetation, and other natural resources to better control where rainwater falls and reduce stormwater runoff. By incorporating natural processes onto school grounds, green infrastructure can play a role in improving water quality on Long Island. Rain gardens, green roofs, rainwater harvesting, and permeable pavement are just a few examples of green infrastructure that can make an impact in reducing nitrogen pollution on school grounds. Teams can choose to build off an already existing innovation or propose a completely unique green infrastructure design. Student teams are strongly encouraged to explore the many online resources available on the LIRPC website. A few past innovative project ideas included designing a bioretention area using soil, plants, and microbes to treat stormwater, and creating a plant and native pollinator garden to reduce nitrogen, chemicals, and overwatering. Winners from this year's STEM Challenge will receive a grant in order to bring their concepts to life and serve as an educational tool for their school and community for years to come.